Okay, hi everyone. So welcome to part 3 of our pressure videos. And in part 3, we want to explore a little bit more about the liquid pressure, and we want to talk about hydraulic systems, right? So the use of liquid pressure in hydraulic systems, alright? So let's just dive right in and let's begin this video. So for hydraulic system, we make use of liquids under pressure, right? And because liquids, right, they have a certain property that makes it suitable for hydraulic system. So first, liquids are incompressible, right? They cannot be compressed, right? They cannot be compressed. So why? Because the molecules of the liquid or the particles of the liquid are close to each other. So the moment you compress, there's no space for them to move forward. As compared to gas, the molecules or particles are far away from each other. When you apply pressure and compress them, you can actually squish them together until they become a liquid. Alright, so liquids in general cannot be compressed because the particles are already close to each other based on the kinetic model. Alright, next, if pressure is applied to an enclosed liquid, then the pressure is transmitted uniformly because of the liquid being incompressible, right? Transmitted uniformly because the liquids are incompressible, right? So whatever force or pressure that you apply on one part of the liquid will be transmitted fully to all the other parts of the liquid. So as you can see over here, right, the water is ejected at equal pressure, right? This water is ejected at equal pressure, right, as soon as you apply a force to this contraption. Okay, so with this, let us go into the application of hydraulic systems. The first one is to talk about the hydraulic press. Okay, so over here, we want to talk about the using liquid pressure to apply force or to transmit the pressure from one part to the other part. Alright, so as you can see at the first part over here, if at x, if you apply a pressure over here at x, right, so you get some pressure at x, and this will transmit the pressure uniformly through the liquid, right, and it will be transmitted uniformly to the second piston with the second area. Okay, so one more time, when you apply a force at area x, this will create a pressure below the region, and this pressure is transmitted uniformly because liquids are not compressible to area y, and because of that you get a force over here at y. Okay, now the thing is that as you can see at the left hand side at x, you don't need a big force, but you can generate a very big force at y. Why is that so? Right, so let us explore this idea over here. Now, because the pressure is transmitted uniformly, the pressure at both sides will be equal. One more time, because the pressure is transmitted uniformly, so the pressure at both sides will be equal. So pressure is going to be equal to force over area. So force over the area of the piston, right? And it will be equal to the force over this area of the second piston. Okay, so force over area equals to force over area because the pressure is the same at both sides, right? So the thing is, because the pressure is constant, if your area is larger, right, the force that you will get is larger in order to maintain a constant pressure, right? Okay, so let's say if you double your area, you're going to get double the force at y. Okay, if you get half the area at y, you're going to get half the force at y. Okay, this is because you want to keep the pressure constant. So what is the first immediate application of this whole setup is you don't need a big area to generate a big force, or more like you don't need a big force at the first area to generate a super big force at the second area. okay, just by changing the area or changing the size of the piston. Okay, so this would be the immediate application, right? Okay, so let us fill in some blank over here. Okay, so let's do some adjustments. So we want to explore the force that we get from y. Okay, the force that we get from y is going to be equals to f of x times ay over ax. Let us rearrange it this way. Okay, let us rearrange this one this way. Okay, now so since the area at y is bigger than the area at x, okay, so you get 1 point something of fx. So because of that, the force at y is going to be bigger than the force at x. Okay, so this would be the first immediate application of the Pascal principle. Okay, so the resulting force will, or more than the force at the second piston will be larger than the force at the first piston if the area is bigger. Right, so let's put this application, right, to the hydraulic brake system. Okay, so let's put this over here to the hydraulic brake system. So over here, like how are we able to use the force from our feet, right, to brake the whole car? Right, of course our feet cannot stop the whole momentum of the whole car, right? So the thing is that for us, okay, we will so they will make use of hydraulic system to transfer the pressure so that we can generate a big force over here. So let's take a look at the first part, right? The force from our feet with a small master piston, right? And this one will channel, as you push in, right, this will channel the pressure equally to a larger piston over here. And because the piston is larger, you get a bigger force by Pascal's principle. You get a bigger force over here. So because of the bigger force, you can stop the tire more effectively. Alright, so if each large piston at the disc has an area twice of that as the small master piston, so if this one is 2 times of the area, the large piston will exert twice the force, right? So 2 times the force over here as well. Okay, alright, so with this, let us take a look at the question to apply this Pascal principle. Okay, so first we have a hydraulic press, 2 pistons with area of 2 meters square. So 2 meters square is the first area. Okay, so 2 meters square first area. Second area over here is 10 meters square. Alright, so we have a load of 1000 Newton, or a motor car is placed on the larger piston. Okay, so what is the minimum force that must be exerted on the smaller piston to lift this load? Okay, so let's take a look at Pascal's principle. So Pascal's principle tells us that the pressure at the small piston will be equals to the pressure at the bigger piston. Agree? So with this over here, the force at the smaller piston over the area at the smaller piston is going to be equals to force at the bigger piston divided by the area at the bigger piston. Alright, so let us put in our values over here. So the force of the smaller piston is what I'm looking for. Area of the smaller piston is going to be 2 meters square. Okay, let me write in the units meter square. Right, so 2 meters square. Okay, next one. The big force is going to be 10,000 newtons. 10,000 newtons, right? Okay, and the area over here will be 10 meters square. So make sure that the units are comparable. Okay, so with this, how do we solve for the small area? Small force. So small force is just times 2 of that. So we have just 2,000 newtons, right? So with just 2,000 newtons of force, we can generate 10,000 newtons of force just by having the area 5 times. Okay, so this would be the minimum force needed. Now part 2, what is the distance that the smaller piston has to be moved such that the load is raised by 1 meter. So with this, we need to make use of another principle called the displacement of the volume. So over here, if you displace the volume over here displaced, okay, it's going to be the volume displaced at this side. Okay, one more time. The volume displaced on the left will be the same as the volume displaced on the right. Okay, so let us take a look at how much volume that we need to displace on the left. Okay, so because liquids are incompressible, okay, no. Okay, because liquids cannot be compressed, okay, so the volume displaced at the smaller piston, okay, is going to be the same as the volume displaced at the larger piston. Okay, so in short, let me just say that V1 is equals to V2. Okay, let's make it easier. Or the V small, V at the smaller piston, is equals to V at the larger piston, the bigger piston. Okay, so with this, right, okay, how do we find the how do we find the volume of a cylinder? Right, so the volume of the cylinder is going to be the area of the base area of the small cylinder multiplied by the height or the length of the small cylinder. Okay, same thing over here. The volume of the big cylinder is going to be equals to the base area of the big cylinder multiplied by the height of the big cylinder over here. Right, so what's the area for the small cylinder? Base area is going to be 2 meters square. And we just need to look for the length or the height of the small cylinder that we need to push in. Okay, area of the big cylinder is going to be 10 meters square, and the height that we need to lift over here is to raise by 1 meter. So the height that we want to raise is by 1 meter. So with this, the amount of space that we need to push in is going to be 5 meters. Alright, so we need to push in 5 meters in order for it to be pushed up for 1 meter. Okay, so now let's take a look at some application over here. Now, so the first thing is you need a small force for a smaller piston to generate a big force at the bigger piston. So this is the first lesson of the day. The second lesson of the day is that you need to push in a lot more for the smaller piston in order for it to lift a small amount at the larger piston. Okay, so so this ends the lesson on the hydraulic system. So one more thing to take note is that, do we really need to remember every single thing in hydraulic system? No. We just need to be aware that they will state that this statement over here: the pressure at one piston is going to be same as the pressure at the other piston. So you just need to make use of the force over area. Pressure equals to force over area. Apply the formula, and we just need to adjust to find the force or to find the area of a certain piston. Okay, so with this ends the topic on pressure. And so please do the questions behind, and when we come back, we'll settle the other parts of the worksheet. So there goes chapter 6 on pressure. That's all. See you.